The last topic that we want to talk about in today's class is the idea of second law efficiency. If you recall, this is where we started the lecture. We said that thus far in the course we've looked at all the first law efficiencies, thermal efficiency, component or adiabatic efficiency. And we said exergy analysis enabled us to look at what we refer to as being a second law efficiency. So to write out a second law efficiency, this can be defined as being the thermal efficiency of the cycle that we're looking at, divided by the thermal efficiency of a reversible cycle. So the second law efficiency can be defined as So what we can say is that the second law efficiency is a ratio of the thermal efficiency of an actual heat engine to that of a reversible heat engine. Another way that we can write the second law efficiency is if we look at what exergy itself is. So another way to think about this in terms of exergy itself is the second law efficiency is the amount of exergy that we are able to recover divided by the amount of exergy that is supplied at a given state. So if we're going to examine exergy and we want to be able to determine the amount of exergy, like we looked at when we looked at the temperature supply or the source at 1500 Kelvin, what we need to do is come up with a useful method of being able to quantify the exergy associated with different forms of energy, be it kinetic energy, potential energy, internal energy, or the enthalpy, or even heat transfer and work. So what we're going to spend a little bit of time in the next lecture looking at is a way to quantify different forms of energy as exergy types. So that is what we're going to be doing in the next lecture. We'll be taking a look at coming up with expressions for the exergy associated with different forms of energy. So with that, I'll conclude this lecture, and I'd like to thank you for your attention. Thank you. Bye-bye.